do some exercise whereby we add two circuits. One where we have the input resistance, and then the capacitor, the non-inverting input being grounded, this being the Vin, R1, I1, capacitor C, IC, and then V out. We ended up with the V out being the integral 1 over RC, the integral of V in t dt. So that means this should be time varying, like a sinusoidal wave or a pulse, whichever way it is, it should be able to be varying with time. And then for the alternative circuit, say that we could have an inductor where we push in the input into the op-amp, operational amplifier, at the inverted terminal, and then instead now have the resistance via which we will be having the feedback from the output. This would be hard, and I do not want to do a lot of stuff and grounding on the non-inverting terminal, and you are supposed to show that the V out will be the same as the minus R over L integral V dt. I'm sure none of you has tried this. Very sure. 100%. Anyone to disprove me? Yes. Okay, now the chalk is here. Come chalk. And show that this is equal to this. How else can I prove that you did? You draw the circuit there, then you derive and give us this.
Now we are going to use this circuit, where we have a resistor and the resistance R. Then we have this thing in. We have the voltage somewhere here. Then we get something like this.
Are you drawing the circuit down there?
Yes. Then we ground there. And we say this is the end. Then here we have the key. Then here we have the voltage out. Then we can have this one is an inductor. Now the capacitor, the resistor is there. Then here we shall have some.
Can you first copy that circuit properly?
Yeah, I have it.
Properly copy as it is. Copy the things as they are.
I think you see this one. Now we shall have call it IL. Then I want to see whether the thing match. It's perfect. Now from there we say that no current will enter through this end. Now you see this current is coming like
Can you
this.
first label the N and the P properly? Okay.
Now here we shall have voltage VP and the PN. But we say this one approximate to this one and it is 0 because if this is equal to this one is grounded. When it is grounded, the potential will be 0. Now, we have a current that passes through the inductor. We have another current that is from the resistor. Now, the sum of these two currents, they are meeting at this point. If we use Kirchhoff's current law, says that the IL plus the I1, this one should be giving us the current from the other end, but we say no current enters this end. This one will be 0. Now our task is to get this and this one. Now if we are to get this one, we shall use this side to get V1. You know better from Ohm's law. We say that if is what? Current times resistance, then we can easily say that we want of the current, and I can say I1 will be the V out, then divided by the resistance, which will be R. We are now together. We can sort out this one. Now here, current that is passing through the inductor. If you know that whenever we change the magnetic field, this is the inductor, it has inductance L. Now we usually have the back EMF in the inductor, and we usually say that the back EMF will be connected to the negative of the rate of change of current in the what? In the coil, because this is an inductor coil. Now times dI the what? dt. And we say that the voltage induced will be the negative of the back EMF, so that we can have the back EMF as the negative. Now the voltage will be equal to the negative of the what? The back EMF. And we can say that the voltage which we have voltage dI dt, this one will be the negative of here, the what? I inductor. I use the L dt. Now my main aim is getting off the what? The aim is getting out the voltage I have it V in. The aim is getting the current. You see that? Now the voltage will be V in. This one will be equaling to, since I want current, I will divide this one this side to be voltage over the inductance. Then this one will be equaling to the current, the what? dt. Then whenever I integrate on both sides with respect to time, then I will get something like the integral of, you know, the body is not going down. You have to utilize the available space. The integral of V in over the inductance L, then dt, this one is a function of time, it's sinusoidal and then anything. But it is varying with the time, that's why we put in time. Will be equal to the integral of the I in the inductor, the what? dt. Whenever we integrate the derivative, we get that function which is differentiated. Meaning the I in the inductor will be equal to the integral, I can call this one the inductance. The inductance is usually a constant. Now we'll be equal to the V what? The V in, then the what? dt. If we have this one and this one, they want us to get off voltage out of voltage. Now that one is something very easy. Now we just put in this one in the position of I, and we put on this one in the position of this one, so that we get 1 over L, the integral what? V in, then the what? The V plus. This one. V out over resistance, and we say this is equal to 0. We want to make this one the subject of the formula. Just relax. You take this one the other side, you multiply by this one. We do it once and we finally say that the V out will be equal to negative. Negative, I'm also multiplying. This one is down. I multiply the other side, it will be up. R over L, the integral of the V in the what? dt. That is it.
Thank you. So how many papers should I give him? Since that is the only thing I have. Yeah, these papers I give you in the practicals. How many should I give him? I have a lot of them. 8. I have a lot of them. It is you to decide. Since he has done his work, it is you to decide. So, how many? 100. 100. Full rim is how many? Do those the papers I give you, do they come from a rim? No problem. Paul, you come for your 100 pieces of paper. Because at least you have shown that you can do something after the... And in the lab, I will always give you time whenever you want. Because you have interest. And your colleagues, is such area, at least I see, make sure you, you be patient with your colleague because he wants to... the reason I'm being... critical on this is that in the lab he disturbed me. Okay, I had helped him before, but this time he was really interested in wanting to know what is going on. Me, I want to explain, you want it now, what if we did like this? So he got to my nerves because I was tired listening. And because of that, now that Agawa is out, I think some of you have a problem. Tomorrow you'll be looking for a job. You may even be needing a reference. And he's exposed more than you are. You come and sit in a chair and you relax. The whole of him goes to pick another chair, and then tomorrow when you want help, you'll be looking at him. You don't know how to create your life easy. I've had an easy life because I know how to treat people good. Including you, whom I don't expect much from. I give you free tea. I give you free sugar. You understand what I'm saying? You will understand later when you have already gone to the field. That's when you try to understand a few dynamics. So, the only thing I'm not comfortable with, Paul, is how you just talk of back EMF, then it is minus. This is Lenz's law. The minus is because the induced EMF always acts in opposite to the change causing it. It's not that. Because it is back EMF, then it is minus. But I won't complain because I did teach you that. Anyone having a divergent view? Okay, so remind me of your, I want to say it on record, your 100 papers. You count them. No less, no extra. And then take your papers. That's a gift I can give. I used to give mathematical sets in when I was teaching senior one. I was teaching mathematics, and then one of the students who got a set came here. So So when he came, he found me teaching physics. So I convinced him to major in physics. He said, no, made me love math. I don't want to do physics. For me, I'm mathematics. And for you, you are unlucky. When I was still rich, I used to give out cassava for, if I asked you the other two names of lands. I'm very sure no one can answer that. The other two names of lands. Don't look at your phones. I can borrow maybe and even give this cassava. The other two, whichever names he has, the other names of lands. If you can tell me those names, I'll give you 50K. I'll come with it next time I come up. I know these days I don't move with the money. 5, 4, 3, 2, 1, 2, 0. You have just missed 50K. Yeah. 50,000. They call it what? The chimpanzee. Hey, the chimpanzee. You have missed the chimpanzee. But because these days I don't move with money, it's hard for me to I have made a resolution that I will spend all of this year without touching cash. Whether I'm buying fuel, mobile money. Whether I'm buying things in the supermarket. Because it has helped me. When I don't have money, I don't waste money. When I meet somebody whom I could have given like 5K, I look the other side. Because I don't have the money. If I meet somebody who insists that he wants money from me, I say I don't have cash. And on the phone, I move with the little money still. I want to transfer money there when I want to do something. So if you say, but I have the phone, I say, fine. They say, see, this is my balance. It's miserable. So they look at me in my suit and they are like, this miserable man who walks around. The phone and which is empty, but in a suit. So we go to the differentiator. If we interchange in this other circuit we had, if we interchange the capacitor and the resistor, then we create a differentiator. Interchange R and C. Please go to the whether Google, whichever place you go to. The problem is that when you go to Google or any other search engine, you get a lot of results. The challenge is looking for the right source of whatever you are looking for. But you will be able to find that much as we did draw the other circuit equivalent, you find some of the circuits like this one. For example, with the R in here, and then with the other, so you have the input there, and another input here, and then you have the output, and then you have the this is the voltage source, and so we can draw it here like this. And then I should have a resistor here. So this is R out. So if you find these diagrams, these R in, don't feel uncomfortable, like he drew something different, now they are drawing it within the it's not a diode, within the operation amplifier symbol inside, and then you find that you still have the R1, for example, here, and whatever else would be there, but with the VP and VN here. So you don't feel bad. You need to go and read about each of the any author. When they are trying to author some information, they look for some way they can make it unique to show that they are doing something, adding something. And that's why you find that, for example, if I use an example of Bostock, you find Bostock insisting on the Victoria approach. Humphrey wasn't bothering, he was all scout. Everything, you wouldn't even know where the formula is coming from. You see him saying that, so this is equal to this, very scout. And then Bostock will show you how to resolve. After resolving, you get a resultant, then something comes out. They're all doing the same stuff. Nericon, you go to Nericon, you'll find that there are a lot of derivations coming from first principles, giving the historical narrative of how something came up, and then afterwards go to the actual thing. So you need to be flexible and focus on the principle. Not the principle of yours, not this one, the principle behind something. Okay? So if we interchange R and C in the integrator, then we achieve a differentiator. So we have the V in, and then the pole, maybe pole. When you are drawing these diagrams, maybe Agawa can will explain to like to you later. Science is so strict. If you are drawing a heart and the left ventricle you draw it in the right side, then it does not become a heart. If you drew a body of a human being and you put the heart on this side, there's nothing here. It's around here. If you put the heart this way and you are saying you have drawn a human body, but the heart is here. But you draw the heart nicely. Have you done the right thing? So when you are drawing, draw things in a proper way. Don't draw the resistor, you are like this resistor. This is not it. Then you draw the operating amplifier, you are like this one here. You didn't draw it like this, but I'm trying to show you, at least the same teacher knows what I'm trying to do. You are drawing this part of the circuit and then you are busy like shading like this. Maybe test 2 I should be, I don't know whether they are diagrams. And I'm going to, some of you again insisted and came to ask for past papers. So I'm going to put past papers of 2024, tests and exam, and even put a marking guide. But I'm going to sit down and make sure that everything for 2025 is new and twisted. Because I mean, what can I do? I went in class, I complained and explained, please don't ask. Then these two fellas came and said, we want to know how things are set. So I'm going to put everything now. I'm going to put everything, even the marking guide, even how the marks are put. For both, for test 1, test 2, there are 3 tests. Test 1, test 2, test 3, exam, even the marking guide of the exam, I'm going to put it on that page. And then I'm going to make sure that 2025 is special. So that I also put it there. If I did this course in 2026, I also make sure those of 2025 are there. And also make sure that 2026 is special. Because I got it. Today I was looking into my collection. I found a lot of nice questions. So maybe that may make you learn a lesson. practically. I'll not say the guys who did that so that we don't crucify them. I'm supposed to interchange the two, and the capacitor was up, so we put it down here. Capacitor are two lines which are equal, sometimes all bolded, looking like the negative of the battery. And then you have this input V in through C, IC, capacitance, current, and then we have the feedback going through a resistor. A resistor is a rectangle, and if you are sure that this resistor was formed from a coil, then you make this. This is fixed, and then if it is variable, like a real start, then you put an arrow through, and if you choose to make it a rectangle, which could be anything, could have been any material that gave resistance, and if it is variable, then you draw it and strike through. That's how the resistances are put. The inductors could be a coil. I don't know, depending on how you fit, you could want to draw it when it is standing, or you draw just the coils like that, or whichever way you could draw it like this, depending on which way. But these two are better. Why would you make something which is almost upside down? And then we ground the non-inverting terminal, and then we have the output as our V out, V in, and then we have the R. This will be the IR. 2, from his way of doing the stuff, personally, I don't know about other colleagues, personally, I don't think there is anything you can answer and maybe it makes me excited. Because I'm asking you what I gave you, and I just want to get your answers on the marking guide that I would have made from what I gave you. So, stick to the methods. When you pass and excel, you can now become frugal. I had one boy who was from Chibuli, so he took my course. Maybe got 40 something. So one morning, I'm in my office. Of course, I told you when I'm in my office early morning, I'm still home. And this fella comes and says, "Sir," he was kind of disappointed. I don't remember, I think he was also doing BSc. Maybe because he was at Chibuli. Any Chibuli fella here? Anyone from Chibuli? I had 6 roommates in his first year from Chibuli. They gave me hell. Now, this fella tells me that, "Sir, I'm disappointed. During school, we used to do hard things. They would give us hard numbers. We would discuss them. Now, with you, you give us simple assignment. It comes in the..." Yeah, you are surprised. It comes in the exam, in the test, and most times comes in the exam. Does not, like he was feeling like I'm not tickling his intelligence. And he kind of pissed me off, you know. You retook my course. According to your other courses, I don't see you having A's in other courses, and you are showing me that I am not touching your nerves. So I chopped off my wires and told him, "Please, you don't come in the morning and spoil my morning. If you had A's, you would have the courtesy to say that I'm boring you. That I gave you simple stuff, you got an A, and then I bored you." And from that time, he dodged me always. I mean, like he didn't want to talk to me. So my point is that follow what, at least for me, it's electronics. Nothing is going to change. Follow what, the way things are given to you. Present them. I'm not asking you to discuss. There's nowhere you find the word discuss or elucidate. You know what elucidate means? I will not ask you to elucidate the use of diodes, because uses of diodes are unique and you cannot invent your own. I will not ask you to discuss the use of resistances in electronics. I will ask you things, I will ask you whether the resistor is linear or non-linear, period. Then tell me it is non-linear or linear. Don't discuss. Non-linear means that it doesn't obey Ohm's law, and Ohm's law is when under state of conditions of volume, temperature, and pressure. Don't do that. You get the point? It saves your time. You will pass, and when you have passed and you are a big man, you can now argue. You understand? You can now argue and even make your own theorems, like I now have one theorem to us. You know it? Who knows, you will say. So at node N here, at node N, we follow through the assertion by Paul is equal to 0. The sum of the currents at node N is equal to 0 simply because you can never have any current going in or getting out of the path. But the current through the capacitor is the same as CV in, and the current through the resistor is the V out minus Vn, which Vn is equal to Vp, which Vp is 0 because it is grounded. This is emanating from they call them golden rules. Okay? The golden rules are the assumptions we had. It is infinite amplification. Then we have infinite input resistance and infinite, negligible output resistance. The consequences of each of those is what gave us consequence of the infinite gain, ended up giving us the differential voltage being equal to 0, and then the other ones ended up giving us other benefits, whereby infinite input resistance would never have any current going in or getting out.
I thought that, well, I don't know what to ask the way you said you shouldn't.
That's
okay. That current, shouldn't it, I think it should be differentiation of something, time derivative of V.
It should be Q. The Q is equal to CV
and I is the QVT.
So, wait a second.
The current
Q is equal to C.
Yeah, fine. And then Q is equal to
I is equal to
I is the Q.
I dq dt.
So I should be an integral of something.
It should be dv in dt or
It should be
okay, so we have Q is equal to CV.
I is equal to
The Q, okay, this is V in. The Q dt will be equal to C dv in dt. Okay?
Yes.
So this is current through this would be equal to C Vn. So I'm forgetting the D, the ddt.
Yes.
Okay, thank you. And then today we are finishing operation amplifier, so that I don't know, I've never covered this section with either it's because I don't know the reason. The time I started this section, you are just there like this. Is it because there is no operation amplifier in any of the experiments? Is it the one operational amplifier, or the amplifiers we did in a common emitter, common collector, and common base?
No idea.
So IR is equal to IR will be the same as the V out minus Vn. Vn is 0, so it will be V out over R. So yes, Paul, it is okay to quote the Ohm's law, but when you get it from here, it feels nicer. When you are having the difference of these voltages dividing by the resistance. And the difference of these voltages here, you have this voltage, since the current is flowing this way, current flows from where you have a high potential to the lower potential. So you get this high potential voltage V out minus the Vn over the resistance gives you IR. But from the golden rules, the Vn equal to Vp, but Vp is grounded, so Vn is equal to 0. So then you get it as V out over R. But if you just throw it there and you say from Ohm's law, IR equals to V out over R, then we can now go on. Someone will now reach there another time. Your students, I mean your students will be teaching in the future, or soon after. Isn't it after this semester? Yeah, in June there. The students will just be looking for where to apply Ohm's law, and you will be seeing. Now, the day they will find that they have to consider the other voltage, many things become very tough. So this would be V out over R, and then we substitute into our equation, and then we have that V out would be equal to minus RC V in. I'm sure each one of you now how to achieve. I don't know whether all of you have done at least an experiment with the functional generator. So experiment E3, E7, E10, I think these ones. If you have done this, then you know how to achieve this sinusoidal, or for 10, for E10 even go beyond to having the square wave, where you can get the frequency response. This is the basis of our next section, which is the digital circuits or digital electronics. So this Vn varying with the time can be sinusoidal. The key sinusoidal, square, and sawtooth. You get them by default. You just choose which button to get. Like we did for the integrator, we look at the alternative circuit. And this alternative circuit, we shall replace the resistor with an inductor and go in via the resistor. So we have P in, and then we have the resistor, since now I'm confident that some of you try to do some work, so I'll give this again as an exercise to give a chance to the other people the chance to do something. So show that when we do an alternative circuit, V out will be the same as minus L over R D. Is it V in or dV in dt? dV in dt. Okay, since we are talking of the differentiator, it should be, that's what you told me, dV in dt. So from next week, if it doesn't over-rain again, of course it is not going to rain badly from next week. The reason it was raining badly, if you remember our theory of the moon viewing on full moon on 17 or 19? 17, it was a lunar eclipse. They call it a blood moon. And then on 29, it will be a solar eclipse somewhere. I'm not sure. I haven't bothered to know which area will be showing it.
USA.
Huh?
USA.
West?
USA.
USA. Whenever Trump becomes president, there's always a strange eclipse. So there will be an eclipse in the US. Now, so that means that throughout this month, we've been having the moon being nearer. And then the forces I showed you would be higher, the evaporation is too much. So during that dry part, and then this one, this new moon, I mean the full moon coincided with the last quarter coincided with the equinox. Equinox is when the sun is crossing, the sun doesn't cross, but it is when the earth is tilting and the sun is going past the equator. So on the 21st and the 22nd, if you were to stand outside, you wouldn't, at midday, you wouldn't be able to see your shadow if you were at the equator. So when you combine all those two, equinox with the last quarter, and then you add on the transition from the sunny season to the rainy season, then you would expect the things that happened in Kalangara. The winds are too high because of the evaporation which took place, and then you have the waves. And then some guy from the meteorology was on TV and he said, and the Indian Ocean is releasing a lot of wind. I'm sorry. There's a way I look at things, and when I see people talk, it's like I'm the one who is confused. So I sometimes just shut up and relax. Because I know, so good enough they had predicted, but you all know that new moon being on the 29th, today is 27, already yesterday was a disaster, today was almost becoming, if it shines today afternoon, very nicely, tomorrow and the weekend it will be very wet. And then we shall relax a bit in the airport, a little bit. And then people will be like, hey, this is climate change, it is now shining hot again. because they have no idea what is going on. Any question? Any questions? So when we look,
where is the God in this rain thing? Because people have been praying for it.
I showed my presentation to some guy. I don't know, I don't want to tell you how I'm related to him. And then I took him through the presentation from slide 1, 2 up to the end. Then he said, I think the sun is the God. That's what he told me, this guy. I don't want to tell you how I'm related to him. After taking him through the presentation, because I mean he had no idea. He came to visit me in the office, and then I told him what I do sometimes. I took him through that presentation I showed you up to the end. And then he said, no, I think he's not a good believer. So he said that I think the sun is the God. Because it does everything. Whether it is formation of the rain, drying our produce, it is the sun. I used to say bad things about God, and then I would get into trouble. Like I'm driving back home, I like knock boda. So these days I don't want to have problems. I want peace. I want peace. I let those who believe in what they believe in what they believe. But for me, if I was having a chance, I would believe in my ancestors. Make them happy. But when I say that, people will say this man is a wizard. If I was a woman, I would say he's a witch. But I mean, the people who died before Christianity came, where are they? Are they in hell? Huh? I think if you are like a grandmother who was so good, it would be nice to pray to her if she was very good. After all, your mother is the one who created you, isn't it? You can't know about your father. But your mother is a sure deal if you are not born in the hospital. Your mother is the only parent you can be sure of.
What about the brother?
You resemble your father. Who resembles his brother, eh? You can't go around saying we resemble each other. I resemble my dad, but he resembles your brother. Okay, so we conclude this part by looking at the slew rate. Slew rate is slew rate of an up arm is the rate of change of the output voltage. I think this could be related to more of what we were doing yesterday. When you are changing the input and then looking at how the output is changing. So the rate at which the rate of change of the output voltage when a large change occurs, at the input. This is the slew rate, is the rate of change of the output voltage when a large change occurs at the input. And this is usually given in volts per microseconds. So high speed op amps have large slew rate. And the slew rates, don't abuse your friends. Good enough elections are over. During our time, some guy stood for election, so it was like, according to Lagrangian, I'll make sure that the posho is very good. And by Benon principle, I'll make sure that also our welfare in other things are good, and Legendre polynomials will help us to negotiate. It didn't go through though. So guys, like this guy has got terminologies. So don't go around calling people that some of you they call it what? Is it called the tagline? Those of you, the guys who go and I say, you are my spirit. Because any small change, any change in the input voltage gives, when that change in at the input, I don't know, maybe when she annoys you, you have no problem at all. So say you are my spirit. I think she will go to the dictionary and look for what you meant. Can range from 0.05 to 900 volts per microsecond. So there are examples which I will post on Mwere, and I will post another exercise on Mwere, and that marks the end of the op-amps. I thought I could finish op-amps and give an introduction to the digital electronics, but I didn't want to spoil. That is like making digital electronics to interfere with the analog electronics. So we start on digital. We start being the digital age. We did the digital migration in 2015 when we threw away all our TVs. All my Nash TVs became useless. I have 3 of them. And I still have my black and white Nash TV. I have a small colored and a big colored, and they are all useless. So when the flat ones came and which have inbuilt decoders, the other ones I just kept them. I'll make a museum probably for my grandchildren to look at the different technologies and how advanced they will look like. So I see those of Friday tomorrow afternoon at 3. And those of others we meet on Tuesday, and we shall start on digital electronics. My paper and illustration, so that I don't eat any minute of your next lecture.